So now that we're kind of armed with a step-by-step process to solve hidden quadratics, let's keep doing it. Previous to our groundwork, we found that if I here's your step one, we're going to let another variable equal to the middle part. Again, I like to use a. You use whatever you want. If I square a, right, square both sides, we end up with a squared equals x to the negative 2. So there's a squared, and there's a. I'll go make the substitution. So I'm going to replace that x to the negative 2 with a squared. I'm going to replace the x to the negative 1 with a, because that's what I decided to be, and minus 3. And lo and behold, what we found is that in terms of the a world, right, in terms of x, it's not quadratic, but in terms of this a, the substitute variable, it is. So I can use quadratic things to solve it. As promised, right, this should factor real nicely. Let's see if I can come up with the right combination here. I know that's got to be a 3 and a 1. I think if I make this a 2x and this a 2x, and I think I need my plus and my minus here. I think that'll get the job done, right? So a negative 1 times a positive 3 is a negative 3. There's a positive 6x and a negative 2x giving me 4a. And then, this is a. And then a 2a and a 2a gives us a 4a squared. So I've got it. All right, so 2a minus 1 is equal to 0, or 2a plus 3 is equal to 0. So we can now solve in terms of a. So on this side, I add 1. 2a is equal to 1. Do a quick division. A is equal to a half. Over here, I would subtract, right? 2a equals negative 3, divide by 2, and a equals negative 3 halves. All right, so again, we've solved this equation in terms of a. I've got to walk the story back. So earlier we said a was equal to x to the negative 1, and right now I have a equals to a half. So if I put these two together, right, that means that x to the negative 1 is equal to a half. Or if x is equal to negative 3, if a is equal to negative 3 halves and a is equal to x to the negative 1, that means my x to the negative 1 is negative 3 halves. So there's basically my walking back. How do we solve for x here? Well, x to the negative 1 basically means 1 over x, right? So we can rewrite both of those like that. And what I'm seeing after that quick rewrite of the negative exponent is the good old trick of cross multiplication. So if I cross multiply here, I get x equals 2. And if I cross multiply over here, I get 2 equals negative 3x. Doing one more division, and we get our other solution, x equals negative 2/3. Oops, okay? And again, what I'm going to use to my advantage, right, this equation is essentially 4 over x squared plus 4 over x minus 3 equals 0. And the only problem it has is if x is equal to 0. So since none of these two answers is 0, right, I'm going to trust the math that I did, and as far as step 5 where I check my answers, I'm pretty confident that these two answers are actually going to work, all right, because it doesn't mess around with the domain. So I'm going to skip the check part here, right, because I just kind of want to concentrate on the main part of declaring a new variable, making the substitution, solving in that new variable, walking the story back, right, and then solving for the remaining variable that we have, right? And so you saw that trick yet again. So same thing down on the bottom here, right? Again, if we take a look at that middle term, we're going to let a equal to that value. If I square it, right, I end up with a squared equal to x. So everything's in order. So this x is going to be replaced with a squared. This square root of x is going to replace with a, and minus 1. So there's our quadratic in terms of a. So I'm going to basically factor it now. Let's see if we can get this factored. I know we have plus or minus 1 to get that guy. And let's see. Yeah, I think this will work. If we do 4a and a, right? So 4a times a is 4a squared. A positive times a negative is a negative 1. My outer is a minus 4a. My inner is a positive a, giving me negative 3a, so we've got it. So the zero factor property says that one of these two guys is 0. This gives us a equals to 1. And if we do some subtraction and some work here, this gives us a equals negative 1/4. Alright, so we got to walk our story back, because right now we've solved for a, right? I want to solve for x. So again, here's what a is equal to. It's the square root of x. And here's what I found a to equal to. So that must mean that the square root of x is negative 1/4. Or if a is 1, that means the square root of x is equal to 1. Alright, so solving for x, in this case, I'd get rid of the square root by squaring both sides. This gives us x equals 1, and this would give us 1/16. Alright, so there's our possible answers. Alright, again, because this guy really has a restriction, right, we got to make sure that these guys work. So let me go ahead and I will check these. So if I plug this in here, right, I get 4 over 16 minus 3 over 4 minus 1, right, finding a common denominator, 4 over 16. This would be 12 over 16 minus 16 over 16. And I kind of see we're not going to get 0 here, right? So this is extraneous. If I plug the 1 in there, 4 times 1 minus 3, square root of 1 minus 1. We get 4 minus 3 minus 1. And here we do, in fact, get 0 equals 0. So that is the true statement. Okay, so I did check that one because of the square root of x having some really restrictions in its domain. Alright, so basically there's the trick yet again, where we let a variable, another variable, again I like to use a, set that equal to the middle of it part, square it to get the variable part in the front, make your substitution, solve the quadratic we get in the new variable, and then you walk your story back and then check your answers. Alright, so there you have it. I think from that groundwork at the beginning, there's a couple more that we're going to take a look at, and so I'll see you in that video coming soon.